so I just have one example because that's what I have, and we don't want to take notes forever, and some of us want to go out to dinner. I don't want to mention any names. Here's how it could be listed for you or prompt you. Yeah? Find where the function f is increasing, where it's decreasing, and find all the relative extrema. So let me see. I got old eyes. Whoop. And here's my function. F of x equals x to the fourth plus 1 all over x squared. Okay? So think about the first derivative test. Think about what we did. Shocker of all shockers. So here's the solution. We have to find the critical numbers first. Okay, so I'm not going to talk about this much. I've simplified the function. Make sure you understand why. I've taken the derivative and simplified it. Hello, algebra. We love you. And then I found the critical numbers. So again, not going to explain that. You ask me if you don't get that. And here, this is important, so I just wanted to make sure you understood this. The increasing and decreasing happens between critical numbers. And if the function decreases, or if the derivative is negative for any test point between two critical numbers, then the derivative is negative for all those values in that region. Okay, think about why. And I just want to sort of come back here. I mean, you can start to look at it graphically. If I have two flat spots, so I have a 0 and I have a 0 for my derivative, okay? I have to, for example here, I have to be decreasing if it's continuous. There is no way for it to change all of a sudden to increasing in that region. Otherwise, I would have had another critical point, another critical number. So that's important. Think about that, rewind that, and think about that again. Make sure you get that. So that beauty of a tidbit of a math thing allows us to do the following. Okay, so when you're answering these kind of questions, or when you're trying to find the max and min points and all the increasing, decreasing, you're going to make yourself a table. Your first thing you're going to do, you found the critical values, the critical numbers. Notice my critical numbers were -1, 0, and 1. I've separated the all the x values into the regions surrounding those critical numbers. And I can pick any test value that's in here. Because listen very carefully. If what I'm going to do works for one test value, it works for all of them. So one test value is enough. Is -2 special? No. I could have picked -3, -4, -5, -5.626. But it has to be in this region. So look at this. This is actually the result of it and the works here. But copy this down and we can come back and look at it in a bit. Okay? This is the final thing of what you're doing. But you must show your work for all of that stuff. Yeah? So you have to, at your test values, tre importante, you plug in the test value in your derivative, not in your regular one, but in your derivative. So I'm just going to leave this here, and you verify. I don't have to talk about it again. You verify, you make sure why I made those decisions. Okay? So did you have enough time to stop? Yeah? And then you sort of see, yeah, I saw why you did that, Dadmare. Now, I picked this problem because it's very weird, and I don't know if you've noticed it yet or not. Be careful. This is why I picked it. X equals 0, which we got as a critical value, and I put it there on purpose. It's actually not even in the domain, because if you look at the original function, it's not even defined there. So I can't make any conclusions about it. If you actually graph the original function, it looks like two parabolas. There's an asymptote at 0. So that's neither a max or a min. Okay? And here are some good AP answers. This is what they're looking for. They're specifically looking for this. A function is decreasing, you give the range, and you give a reason, because the derivative is negative there. Good enough. It's increasing in the range because the derivative is positive there. Good enough. It has a relative minimum. If this is the case, this is what you need to write, because the derivative changes from negative to positive there. All right. Have have a summary, and there's your question, and I am off to dinner. Bye-bye.